Hi, in this video we are going to sort a list of numbers using heap sort. You can think of heap sort as a specialized selection sort where we always know where the largest number is. This is how it goes. Rearrange the list so that the largest number is at index 0, the first element. Then swap the first element with the last element. Then repeat this whole process for a smaller list that ends right before the newly sorted element. It sounds pretty easy, right? The only question is, how do we make sure that the first element is always the biggest one? Luckily, we have a data structure called a maximum heap that does exactly this. It uses an indexing scheme with three elements at play. There's a root, a left child, and a right child, and it has a property that makes sure that the root is always the greatest of the three elements. When we find that this property does not hold, we will make a swap so that the root becomes the biggest, and we repeat this whole process for the child that was updated by this swap. It might sound complicated, but trust me, it's not that complicated. This is a good time to pause the video if you would like to type it up yourself. Alright, let's start. First, I need a couple of variables. I will just make a copy of the numbers. I will need the last element, which is going to be the length of the array, and I will need a root element. I will just pick 0 for this for now. First, we will need to find the largest index of the three. I start with root, and then let's go for the children. The left child is twice root index plus 1. With this we can check if this is a valid index in this list, and if it is bigger than the root, then the largest number so far is the left. Let's repeat this process for the right child as well. It is twice the root plus 2, so following the left, but the condition is the same. If the right index is a valid element of this list, then let's check if right is bigger than the one that we have found so far, so largest. And in this case, the largest is going to be the right index. Now let's also print this to make sure we see how we are making progress with this algorithm. So the root is array root. The left child is array left, but only if the left index is actually a valid index. Otherwise, we don't have a left child. And the same thing for the right child, array right, but only if the right index is a valid element of this list. Otherwise, we don't have a right child. Okay, now we can run this code and see if it actually finds all the three elements. Yes, there you go. Okay, we can see that the right child is 8, which is bigger than the root, so there will be probably a swap. Let's write that code. If the root index is not the largest, then we will need to make a swap. Let's also print this fact of swapping things so that we can follow what's happening. So swapping array root with array largest. Let's actually do the swap. That's gonna be root and the largest, and in the opposite order, largest and root. Excellent. Once we have this, we have updated one of the children, and so the property for that particular child might have broken. So we need to perform the same exact operation for that subtree. We will achieve this by calling this exact same code, and we can do that by putting this into a function. I will call this function sift down, and it's really simple. Repeat the same thing for the array. The last element will still be the last, and we are going to pass down the largest index for the root. Of course, there's no such function yet, so let's define it here. call it shift down as we said we would. It gets the last and the root elements as parameters, which points to the same array. Excellent. Now we have all this typed up. Let's call it and see what it does. Okay. Let's create a variable first, because we might need to do some funky things with this. So I will choose I to be the middle element within this array, and I will just do a shift down operation for this. The last element will be the length of the array. There's no change there, but we are going to go from I as the root. Now when we run this, yes, it starts with the subtree at 8, which is good. It doesn't have a left and a right child. That's perfect. Now if we actually want to build a proper max heap from this, we will have to put this into a loop. So let's just do that. We will use this, keep this variable I, and while I is greater than equal to 0, we do the shift down operation. And then we make I1 smaller because we start from the middle of the array and we want to go backwards. Once this is done, we will have a maximum heap built. And let's take a look at how that actually looks like. Running it, at the end of all the swaps, we'll see it is indeed the biggest element, 8, at the first element of this array. Fantastic. What we need to do next is to swap it to the last element, and then we can repeat the whole process. Now, I will also declare another variable for this, which is going to be the length of the array minus 1, the last element, the last valid index, and we will need to make a swap. This is where we go next. So swap array 0, the first element, with array j, and actually make that swap. Swap 0 and j, and the other way around, j and 0. Fantastic. Now, as you might guess, this breaks the max heap property, so once this is done, we will have to restore that order. So we will have to call the shift down function once again, and it's going to be also for the array. The last index will be j, and the root is always 0 because that's what we have changed. All right. And here at the end, we will also have a max heap. But this time, it's a shorter list, so it's just between the first element, and j. So we get back the max heap after this. Let's take a look at what we are doing. Yes, indeed. Here's the first max heap. We swap 8 with 3, and then we get the max heap for the one shorter list. Okay? To be able to sort the whole array, we will need to make another loop. This is going to be using j. While j is greater than 0, repeat this process and make j1 smaller. And then at the end, we are supposedly getting back a sorted list, sorted numbers, sorted array. And there you go, it is all sorted now. If you would like to make this look nicer, you could call this code heap sort, which gets an array and just call that function for the numbers list. And there you go. It's nice and it works as we expected. That is it. Thank you very much for watching. If you would like to see more videos like this, please subscribe. See you.